All right, everyone. So in this video, we're going to start the conversation of dividing polynomials. So in the previous video, we talked about the remainder theorem, which is really handy for determining if something is a factor, but there's quite a heavy arithmetic lift there. So if you want to find out whether something is a factor, you have to plug in to a polynomial that could potentially be quite long. There could be a lot of big coefficients, a lot to keep track of. So this video is not going to quite speak to that yet, but it's going to build up to the next video, which will absolutely do so. So in this video, we're going to talk about what's called long division of polynomials. And I actually want to start by reminding you how long division worked like before we got to polynomials. So let's say that we were to divide 347 by 7. Okay, I'm making these numbers up. They're not significant. So how do we do this? Well, rather than dividing the whole number by 7, we look at the number in pieces. So for instance, we say, does 7 go into 3? No. But 7 does go into 34. How many times? In other words, what would you multiply by 7 to get as close to 34 as possible? And the answer there is 4. 4 times 27 is 28. Subtract. 34 minus 28 is 6. Bring down the 7. Repeat. How many times does 7 go into 67? So, in other words, what is the thing that you would multiply by 7 to get as close to 67 as possible? And the answer there is 9. 7 times 9 is 63. Subtract. 67 minus 63 is 4. There's nothing left to bring down. So what we have at this moment is the remainder. In other words, 347 can be divided by 7 evenly 49 times, and then you have 4 left over. So 49 is our quotient. So to kind of finish this little mini example, we could even say that 347 divided by 7 is equal to 49 plus 4 over 7. And some of you might even say, oh, you can write that as a mixed number, 49 and 4/7. Okay? And what we don't really do much of, but what we're going to start doing with polynomials, is we can call this the quotient remainder form. In other words, we are specifying how many times 7 goes into 347 and what's left over. So let's do a very similar example, except this time, let's do it with polynomials. And I'm actually going to do several examples, and this first one I'm going to do down here below. So let's divide x cubed minus 2x squared plus 5 by x minus 2. And we're going to write this in quotient remainder form. So I'm going to actually write out quotient remainder here, but in future examples, I'm going to just write QR to save a little bit of time. All right, so it's going to look very, very similar. And here we are. Now, I mentioned this to you all before. Remember in our very, very first example of polynomials, we talked about skips. Notice how this one, we don't skip from x cubed to negative 2x squared, but then we do skip from 2x squared to 5. There would normally be an x term in here, but it is missing. So what I'm going to do for our long division is I'm actually going to leave a little space. And if you want, you could even write plus 0x, okay? So this is kind of a placeholder. I'm actually going to write that there. that just to kind of remind ourselves that this is where the x term would have gone, we put that little 0x there. Okay, and then we're going to divide this. And you know what I'm going to do? I'm going to delete the placeholder because it's taking up space. I'm going to delete the placeholder words. So plus 0x plus 5. And then I'm going to divide this by x minus 2. All right, so we're going to take exactly the same approach as we did with the long division example up above, except this time we're only going to focus on the first terms. So what would you multiply by x to get x cubed? All right, so here goes. You would multiply x by x squared. Now, I'm not going to write this every time because it'll make my writing convoluted, but I'm going to distribute the x squared in like so. So that gets me x cubed minus 2x squared. Now check it out. When I subtract the second row from the first row, what I hope you will agree with me on is, wait a minute, it all cancels. So there's just nothing left. I'm going to put my little minus sign there. There's nothing left. And so you say, well, okay, but I'm going to bring down more stuff. Yeah, but the next thing to bring down is 0x, and that's just a placeholder. That's not even a real term fully. So we bring down the 5. And you can't multiply x by anything and get 5. So as it turns out, this was a great first example because in just one step, we see our remainder. So our remainder is 5, and our quotient is x squared. So if we wanted to write this division in quotient remainder form, we could say x cubed minus 2x squared plus 5 over x minus 2 is equal to x squared plus 5 over x minus 2. So that is the quotient remainder form there. So that was the first example. Let's do another example just to make sure that it's not always so short. So let's try something like 5x cubed minus 7x squared plus 3x minus 7. And let's divide it by x plus 4. Okay? So here we go, writing it out in long division format. Notice that in this case, the polynomial that we're dividing doesn't have any skips to it. So I don't need to worry about any placeholders. Okay, same thing. What would you multiply by x to end up with 5x cubed, right? So we're focusing on those first terms. 5x squared. Now we'll distribute through. So we have 5x cubed plus 20x squared. And now we're going to subtract. Of course, by design, the 5x cubes cancel. So we have negative 7x squared minus 20x squared, which is negative 27x squared. Bring down the 3x. So we bring down one term at a time. Same thing. What would you multiply by x to end up with negative 27x squared? That's minus 27x. So we have, again, distributing. I'm not going to do the little dots because I don't want my picture to get too convoluted, but we have negative 27x squared minus 27 times 4 is 108. And again, we're subtracting. Notice, by design, the first terms cancel, and now I have 3x minus negative 108x. So the two minuses turn into a plus, and it becomes 111x. And the last thing I have left to bring down is the minus 7. Same, but last time. What would you multiply by x to end up with 111x? 111, of course. So we have 111x plus 444. And then we subtract. And so we have negative 7 minus 444. That's negative 451. There's nothing left to bring down. So this is my remainder. And this is my quotient. So in quotient remainder form, we can say 5x cubed minus 7x squared plus 3x minus 7 divided by x plus 4 is equal to 5x squared minus 27x plus 111 minus 451 over x plus 4. So I just want to highlight that. This is the quotient remainder form. All right. So I want you to notice something before we quickly talk about one other example. And that is, and I'm going to write it up here, notice the redundancies. And what do I mean by that? I mean, notice how much we write the same thing over and over and over again. So check it out. This 5 at the front. It was once written here, again here, and again here. We didn't need to write it all 3 times. We could have just said, okay, the 5 is the leading coefficient. That's going to be the first term in my quotient. Now check it out. The 27 got written 3 times. These 2 times, it really didn't need to show up. Both of these were sort of wasted writing. All we had to say was, well, when we multiply the 5 by the 4, that 20 is going to get subtracted from this negative 7, and that's going to give us the next term of our quotient. By that same token, right? So first of all, of course, the 3 got written twice. Did it really need to get written that second time? I mean, yeah, okay, we're writing it down, but maybe we could have just known that. And then look, this 108, that's 27 times 4. We could have anticipated this negative 27 is going to get multiplied by this 4, and then it's going to get subtracted from this 3. We didn't need to rewrite the 3. And we also didn't need to write the 111 3 times. So there's lots and lots and lots of writing. There's writing things over again. And yes, it works out and it all makes sense, but very, very, very inefficient. So some of you might be thinking, my God, she's trying to like pitch this as like an improved way of finding the remainder. This is awful. And you're absolutely right. This is a very inefficient approach, but what I'm hoping to have you notice is there's lots we can cut out. And there's ways that we can make this process way more efficient, and we'll talk about it in the next lesson. Before we move on, I just want to show you an example that I think comes up in your homework number 16, which is that we can divide any 2 polynomials by each other. So let's say that we have 7x to the 4th minus 2x squared plus 5x minus 7. Okay, and let's say that instead of dividing it by x plus or x minus something, say that we want to divide this by x squared minus 5x plus 2, right? So I really want to stress that even though we don't do this very much for our purposes, you can absolutely do long division between any 2 polynomials. So check it out. We'll need a little bit more space, right, because we're dividing by a longer polynomial this time. Okay, and notice there's a skip, right? We skip from 7x to the 4th to 2x squared. There might normally be an x cubed term here, but since it's not there, I'm going to put a placeholder. Okay, there are no other skips, so here we go. All right. So exactly the same approach. We look at the first terms. What would I multiply by x squared to get 7x to the fourth? I know, 7x squared. So now we distribute through. I'll actually put the little dots here for this first one. So we have 7x to the fourth minus 35x cubed plus 14x squared. Don't forget we're subtracting, so we want to be paying attention to signs. The 7x to the fourths cancel. Now check it out. We have 0x cubed minus negative 35x cubed. Two minuses make a plus, so this becomes positive 35x cubed. And negative 2x squared minus 14x squared is negative 16x squared. Bring down the 5x. Okay, same question. What would you multiply by x squared to end up with 35x cubed? That's 35x. Let's distribute. So we have 35x cubed minus 175x squared plus 70x. Okay, so now we subtract. The x cubes cancel by design. Then we have negative 16x minus negative 175x. Those two minuses turn into a plus. So it becomes 159x squared. And then here we have 5x minus 70x. So that's minus 65x. And we just have the 7 left to bring down. There. And last time through, what would you multiply by x squared to end up with 159x squared? 159x. So we have 159x squared minus, oh boy, 795x. Oops, excuse me. I wrote an x when I shouldn't have. So this shouldn't be 159x. It should just be 159. And then 159 times 2 is 318. So, okay, cool. We're going to muscle through this, but we're almost done. So don't forget, we're subtracting. Then we have negative 65 minus negative 795. Those two minuses turn into a plus. So this becomes 730x. And then negative 7 minus 318 becomes negative 325. There's nothing left to bring down. You can't multiply x squared by anything without having to divide an x out and end up with 730x. So this is our remainder. And this is our quotient. So in quotient remainder form, we can write this as 7x squared plus 35x plus 159 plus 730x minus 325 over x squared minus 5x plus 2. So this long division business is really, really inefficient, and in the next video we'll talk about some ways to improve on that. But I do want you to notice that any two polynomials can be divided by each other, and any quotient of two polynomials can be written in quotient remainder form. So stay tuned for the next video in which we talk about ways to really tighten this process and make it go much faster. I'll see you soon. Bye.